Hello. In today's class, we're going to talk about, in another episode of Language Insight, we're going to talk about templates. So here we are using a little bit of C++ to implement some things for our better use of our languages. So let's begin. First of all, I would like to talk about the concept of template. So, dear subscriber, we have this concept which is really important. So when we have a template, we don't have to declare, for example, a type directly. We can choose a type after we use, actually in the moment we use in the main function. So actually, for example, if we have two numbers, 5 and 6, for example, and here I've taken from C++, the source here, also in the description. And actually, I have done, and I'm bringing this video because I think it's an important concept for you subscriber to go ahead and study more about this topic. So we want to get the max element here in this case. So here we have two elements, right? For example, 5 and 6, and we want to find the maximum. So in this case, it's 6, right? So we're calling the function here. So let's begin with the template. So a template is, as the name says, a template. And we begin with the word template, with class and an identifier. Here a type name and an identifier, which is the type T here. But it can be any letter as you wish. So, and the function declaration here. In this case, the function declaration and template class T. So we have a function getMax of type of return T, in this case result here, and we pass two variables, two parameters, in this case of type T also. And when we call it, we use the function name, which is getMax, with the type, which is int, and so we're giving the type here. And this type here is actually this T here for I and J. And we have also used that. And we know that we have already used that, so we didn't even need it to have used this thing here, because I and J are of type int, and naturally we use like this. So very good. And we have another function for long, and I suggest you try to implement this code here in a different way. For example, in this case, our result's going to be A if A is bigger than B, and otherwise it's going to be B. So if we want the reverse to compare, we would use like this. So it's going to print A, actually, if A is more than B, so A, and if A, in otherwise, we have just B. So that's our function here. So let's go and try to implement, as we have seen a little bit. I recommend you to try to implement this. I recommend you to pause actually and try to implement this template class here. So let's begin. So we have the class and we have a type T, and we want a function called average. That's going to have two parameters actually, which are of type T in this case. And what we're going to do, we will put in the result, and the result is going to be the average between A and B, and we're going to return just the result, which is pretty clear. And here we're just going to, for example, declare A equals 5 and B equals 7, int res. And what we're going to do, we're just going to, so this is the function here, function declaration. Our type here in this case is going to be int. So when we call the function, we have to just put average. We are going to call the function average equal of type int. We don't have to put in this case because we know the type here of A and B, and the parameters A and B. We just have to print, just to throw to the screen the average, which is res and break line. So actually, that's how it works. So let's copy the code and execute. And for example, this here. And the code gives the average, so very good. Another thing that I would like you to try before looking at the result is the following code here to calculate the standard deviation, which is pretty simple also. And I recommend you can see the formula online and try to implement the code here. And this code is going to be available on at GitHub. So it's pretty simple code, but just try some concepts. And last but not least, what we're going to talk is about real language, right? So we're going to the source is from C++, and we are going to change a little bit to do something interesting. So we have a template, a class, but it's just for returning an element plus one here in this case. So we have a constructor here, and here we have this of type T increase, which is this a function that returns the element plus one for some element. And here we have the element receiving the value of arg, right? So, but this template is not good enough for example, we want one element more, but we could argue that this element more could be, for example, the change from capital letter uppercase to lowercase letter, for example. So in this case, we have to use the following specialization, and we're going to talk more probably next time. And so we have the template here. This is the way we specify it. We use the first part template with these this way. Class contained the same way here. And also, we want to put a type here more because we want to use char. So char element is the element that we want to give as a parameter, and our return is going to be the opposite. If it's a lowercase, we want to have, for example, if we have uppercase, we want lowercase, for example. And we have a constructor here. And we will use, in this case, my container char. So we are using the ASCII table, where the difference between these A minus big A is actually minus 32, if I'm not wrong. But I hope you get cleared a little bit more when we go through this code. So here we have the constructor. We just pass an arg, and the element receives arg. Char lowercase, so this is a function that returns an element. In this case, we're going to use our if our element, in this case that we're passing j, uppercase j, and we're asking, is the element bigger equals a and smaller equals z? Yeah, it is. So naturally it converts to numbers for doing this. Element plus equals a minus a. So this thing, a minus big A plus the element here is going to give the element with changed case. For example, if it's a lowercase, it's going to, if it's an uppercase, it's going to give lowercase in this example. And to do the contrary, just apply the change of signal. Actually, this case is pretty simple. If we want to do the contrary, to just to reverse the signal here, we put minus A. Actually, we have just to put minus A here and plus A, but actually it's better to put this small here after this, and here it's going to give the opposite. But we should also change this because actually it has to be smaller A and smaller Z here. So going back to the older case. All right, so this is good. And this is an episode that I wanted to talk more, just to give some hints about what we need really to implement more things. So this is all for today, and we're going to talk more about next episode.